Hi everyone, it's Beau speaking. Welcome to my web-based learning object presentation. In the next few minutes, we're going to introduce you to the following sections of this presentation, starting with the background to talk a little bit about what's behind the development of this object, discuss the technology I use to physically put the object together, go through the development and deployment cycles of the project, successes and challenges that I endured along the way, and finally, users will be able to experience the learning object and provide it some meaningful feedback. From a concept perspective, the robot in the photo shown can be programmed by students to move in 3 different ways. Students need to be able to distinguish between 3 common ways to move a robot, or referred to in the automation world as motion types, before they can start programming them. My learning object introduces learners to the difference between linear motion, joint motion, and circular motion with respect to an industrial robot. The learning object is intended to offer students an opportunity to explore motion concepts as follow-up to the traditional classroom presentation. Any student with a web-enabled device and internet connection will be able to access this learning object on their own at any time. A form of assessment with immediate feedback has been included in the learning object for students to check their concept mastery before they get to the lab and develop their skills physically. Kay in 2011 suggested that in the design of learning objects, the use of interactivity, clear feedback, and graphics or animations that support learning are desirable. From a knowledge development perspective, according to Knowles, adult learners tend to develop a self-directing profile with a desire to control their own learning process. So as such, content modules in the learning object are arranged so that learners can choose between one of 4 modules and complete them in the order that they select. From an audience perspective, the learning object was developed for adult learners enrolled in an introductory automation course in their 2nd year of study in an electronics or electromechanical engineering technology program at Durham College. The class is comprised of male and female, domestic and international students with previous electronics experience, and they range in age from approximately 18 to 35. Looking at the tools that I used to create this learning object, we first off start with TechSmith's Camtasia, which is a screen recording and video editing software that was initially released on October 28, 2002. For the creation of the learning object specifically, I used Camtasia to crop unwanted sections of raw video clips and incorporate transitions where the merging of multiple video clips was necessary. A unique feature in this software gives the user an ability to add color-coded descriptive pointers, as shown in the screenshot, and put those pointers directly over key areas in video clips. Overlaying video directly with text descriptions exemplifies Clark and Meyer's contiguity principle that states when words and pictures are integrated, people can hold them together in their working memories and therefore make meaningful connections between them. Now, the primary tool utilized to develop and publish the learning object was the trial version of Articulate's Storyline 2. Storyline was initially released May 2nd, 2012, and shown here in the top right is a brief snapshot of the storyboard created using the software, which is a comprehensive course authoring tool that allows users to create and publish scalable interactive e-learning modules. Research literature and professional publications support the selection of this software as the primary development tool. Dwakar, Podwarden, and Murthy shortlist Articulate software as one of the top 3 e-learning content authoring tools, founded on pedagogy, usability, and technology criteria. From a professional perspective, Articulate Storyline 2 is the preferred content authoring tool of the e-learning development department at Durham College. From a development perspective, the first step in creating the learning object was to identify a specific learning outcome in an automation course that has been observed to be challenging for students to comprehend when we use traditional lecture presentation means. Following this, a review of existing learning objects in robotics education was conducted to evaluate how other course authors have represented and assessed robot concepts using learning objects. Each section of the learning object was then considered to lead toward the content development videos that we would require, and a broad storyboard layout was conceived. As shown in the screenshot, a lab-installed IP camera was used to take videos of the actual robot that students would be using. In parallel with content development progress, e-learning development tools were researched and reviewed to determine which one could best bring the storyboard to life. Once Storyline 2 was chosen as the primary development tool, experimentation with a downloadable template and self-training began, so I could learn how to create and publish an interactive learning object that includes a self-assessment quiz. Looking at the deployment process, the learning object discussed here was developed for a unit that runs in a winter semester course from January to April. Since a live class was not accessible given the timing of this design challenge, 6 electronics faculty and 2 former course students agreed to review the object and provide me with feedback using a qualitative survey that I developed, as shown in the slide. Relating to the effectiveness of the object, a faculty assessment suggests the video, coupled with the audio narration, makes it easy to understand the concepts of motion types. An international student explains, when it comes to studying for the tests, this is a good way to give the students important information that is easy to access. From a constructive perspective, a faculty member stated, perhaps you could add numbers to the points on screen or add colored dots to indicate the physical position of the 3 points on the paper. And in this sense, they were referring to one of the specific videos in the learning object. And as you will see when you experiment tonight, I took that feedback into account and made the revision. From a success perspective, I'm first off proud to say that I have developed a web-based learning object that I will be implementing in the winter 2016 semester. The shell that I have now created will function as a template that can be used to efficiently develop more learning objects in the future for the automation discipline. Along with acquiring the skills needed to create effective e-learning modules, I have most importantly learned how to develop learning objects that are grounded in teaching and learning theory and instructional design principles. Professionally, this experience will directly influence the learning opportunities that I can create for my students in conceptual areas that require increased practice and representation using multiple modalities. From a challenge perspective, the application of text overlay descriptions in Camtasia had to be researched to obtain desired results. Articulate Storyline 2 software was completely new to me prior to this challenge, so a significant amount of time was spent with the interface in order to create a publishable learning object. Furthermore, some of the instructional design principle discussions surrounding learning objects in our Learning Tools course were discussed after my learning object deployment phase and once feedback had been collected. It'd be helpful to have design knowledge and recommendations in hand prior to publishing the learning object for review. As stated in my respondents' feedback forms, some issues with browser compatibility arose, which were addressed by using Google Chrome as the primary review browser. Since the course that this learning object intended for runs only in the winter semester, I had to be creative in determining how I could obtain meaningful feedback. Finally, since Articulate Storyline software is only a few years old, published literature assessing the pedagogical suitability of the tool is limited, so professional appraisals were also considered when researching a suitable learning object creation tool. Looking at the future, the following is a list of recommendations and points to consider in the future development and implementation of web-based learning objects. The points are drawn from respondent feedback surveys and my own learning experiences in this project. To improve upon the effectiveness of this learning object, videos could be added to show the full view of the robot performing each motion type over a longer span. Second, in order to build on the public reusability of the learning object, further browser and handheld device testing is needed to deliver a fully accessible experience for all learners. Finally, from a learning assessment standpoint, a reflection activity could be assigned as follow-up to the learning object. Learners could be asked to describe the new concepts that they've learned in their own words and post any outstanding questions about the topic to an asynchronous discussion board before applying the concepts in the hands-on laboratory. Thank you for reviewing my web-based learning object presentation. Now let's head back to Adobe Connect so I can provide you with a link to test it out.